the third topic for this lecture, which is permutation. What is a permutation? So by definition, a permutation is the several possible ways in which a set or a number of things can be ordered or arranged. Okay, to make it more visually appealing, let's take that I have these three letters A, B and C, and I want to arrange all these letters. So how many different arrangements are possible? I can either have A first, then B and C, or I'll have A first, then I'll have C and B, or I can have B first, then C and then A, or I'll have B, A and C. If I take C first, I will have C, A and B, and then C, B and A. So here you notice that these three letters A, B, C can be arranged among themselves in how many ways? 6 ways. I have 1 way, 2, 3, 4, 5 and 6. So these three letters A, B, C and C can arrange themselves in how many ways? 6 ways. And all these words are different. Okay. So by permutation we mean arranging different things, arranging the given things to us. This 6, if you carefully notice, is nothing but 3 factorial. I had 3 letters, so number of permutations for these 3 letters are 3 factorial. What is 3 factorial? The first thing we discussed is 3 into 2 into 1, which is nothing but 6. So let's see the type 1 in permutations. So the type 1 is that I have to select and arrange all the persons or things at the same time. For example, I had 3 letters A, B and C, and I had to arrange all these 3 letters. Like I don't have to select 2 or 1, I have to select all these 3. So we found out that the answer was 3 factorial. So let's take another question on this. Suppose there are 3 persons X, Y and Z, and there are 3 posts. I have the head, the deputy head and the secretary. In how many ways can these 3 posts be distributed among these 3 people if all of them are equally qualified? So let's write down what's given in the question here. I have 3 people X, Y and Z, and I have 3 posts. I have to choose a head, I have to choose a deputy head, and I have to choose a secretary. So how do we solve these kind of questions is, see, what you need to notice here is, let's say that I choose X as the head, the first, and Y as the deputy head and Z as the secretary. So this is the head, this is the deputy head and this is the secretary. Now this permutation or this arrangement is different from if I choose the same head but I change the deputy head from Y to Z and the secretary from Z to Y. So these are actually 2 different combinations or 2 different arrangements. So what is the answer to this question? Simply because I have 3 people and I have to arrange all of them. See, all of them are equally qualified and all of them have to be selected. So the answer is simply 3 factorial, or in other words 3 into 2 into 1, which is 6. This would be more clear when we discuss the other type, which is the type 2. What happens is, in type 2 is I have to select R persons from a given set of N persons. So for example, if I am given 5 people, I have to select and arrange only 2 out of them, not all 5, only 2 out of them. So let's take a question on this. See, we have the same question as before. I have 3 persons X, Y and Z, but now we have only 2 posts. I have the head and the deputy head. There is no secretary here. So in how many ways can these 2 posts be distributed among these 3 people if all of them are equally qualified again? So it does not mean that I have to select X or I have to select Y or I have to select Z. All of them are equally qualified, so all of them stand an equal chance of getting any of the 2 posts. So how do we solve these kind of questions? I have 3 here. Out of these 3 people, I write P, and here I write 2. Out of these 3 people, I have to select 2 people. Okay, so why do we write P here? Because if X is the head, let's say X is the head and Y is the deputy head, and in other case Y is the head and X is the deputy head, these two are different cases. Though we are selecting the same people in both the cases, but this position is different. So these are two different cases. That is why we write P here, because we are arranging them into the posts also. When we discuss combinations, it will be more clear when do we write P and when do we write C. So 3P2 is nothing but 3 factorial by 3 minus 2 factorial. Okay, so this gives me 3 factorial by 1 factorial, which is again 3 factorial, which is 6. So a general formula for this is I have NPR is equal to n factorial divided by n minus r factorial. Okay, so keep this in mind. This formula is a really important formula here. I have explained you with the help of a question. Also, if we do it by the fundamental principle of counting, I have 2 spaces here. One is for the head and the other one for the deputy head. In how many ways can I fill this space? In 3 ways, because any one of X, Y and Z can come here. Now one of them has already taken the head's place. Let's say that Y has already been selected. So for the second place, I have only 2 ways, either X or Z. So since I have to select a head and a deputy head and comes here, so I will multiply these two and I will have 3 into 2, 6 ways. So in both these methods, 3P2 or the fundamental principle of counting, we get the same answer. For more clarity, let's take up another example. There are 4 flags: red, blue, white and green. How many signals can be made using 2 flags at a time? So this is again the case of N, P and R. Why N? Because we have 4 flags. So N here is 4. Why R? Because I have to select only 2 flags out of those 4 flags. And why do we have P? Because here arrangement matters. For example, let's draw a flag here. I suppose that this is the red flag and this is the blue flag. I have to use 2 flags for a signal, so this is one signal. Now this signal is different from I have a blue flag on top and I have a red flag on the bottom. So these 2 signals are different, though I have the same 2 flags, red and blue and red and blue, but what occurs on top and which one is below are 2 different cases here. That is why this P occurs. So I hope everything in this formula is clear. N is equal to 4, R is equal to 2, because N is the total number of flags, R is the number of flags we want to select, and why is P? Because arrangement here matters, which flag is on top and which flag is on the bottom. So what is the answer to this? 4P2. What is 4P2? 4 factorial by 4 minus 2 factorial. So I will have 4 factorial divided by 2 factorial, which on solving will give you 12 as the answer. So this is the first method of solving. There is another method for solving, the fundamental principle of counting, which we discussed before. So I have 2 spaces to be covered because I need 2 flags. So the first space can be filled up in how many ways? 4 ways, because I can choose any one of the flags for the first place. Now since the first flag has already been chosen, for the second place we have how many candidates? Only 3. And since I have to choose the first flag and the second flag, so I will use a multiplication sign here and I will get the same answer as 4 into 3 is 12 as I got here. So by both the ways, any way in which you feel comfortable, you can solve this question. Let's take another example. There are 4 flags, just as the previous question. red, blue, white and green. How many signals can be made by using any number of flags at a time? Now this is the tweak here. I am telling you, you can use any number of flags. So I can use one flag, I can use two flags, I can use three flags, and I can use four flags. So let's take one by one. If I choose one flag, how many signals can I make? Out of four flags, I have to choose one flag. So 4p1 is how much? 4 factorial by 4 minus 1 factorial, which gives me 4 factorial by 3 factorial, which is nothing but 4, which is also very intuitive, because if I have to choose one flag out of 4, in how many ways can I do that? Only in 4 ways. Let's say I have to choose two flags now. This is the case we've already done. So this is 4p2 and this is 12. I'm straight away writing the answer because we've already discussed this before. Similarly, if I have to choose three flags, what is the formula? 4p3. So I'll have 4 factorial by 4 minus 3 factorial, which is nothing but 4 factorial by 1 factorial, or 24, which is nothing but 4 factorial. If I used to use all the 4 flags, this is the case which we discussed in the very beginning, that I have 4 things and I have to arrange all those 4 things. The ABC example or the XYZ example, in which there were 3 posts. So this is the similar kind. So I have 4 flags and I have to arrange all 4 of them. How can I write them? 4p4, which is nothing but 4 factorial by 4 minus 4 factorial. This will give me 4 factorial by 0 factorial. 0 factorial is 1. So I have this 4 factorial. At that time I told you straight away write 3 factorial for ABC. So here you notice why, because I have to arrange 4 flags. In how many ways can 4 flags be arranged? When all of them are taken in 4 factorial ways, which is again 24. So what is the answer here? Either I will use one flag, I'll have 4, or I will use 2 flags, or I will use 3 flags, or I will use 4 flags. The total number of ways will be after I add all these. So I have 4 plus 12 plus 24 plus 24, which is 64 ways. Why did we add these different ways? Because this condition is of or. Either I will use one flag, or I will use 2 flags, or I will use 3 flags, or I will use 4 flags. So whenever there is an or, we have a plus sign. So that is why we added the different number of ways. I hope this is clear. So we move on to the next question. Find the number of permutations of the letters of the word caption. Now I believe this is simple. This is a sitter question. I have caption. How many letters do I have? 1, 2, 3, 4, 5, 6 and 7. Okay, so I have 7 letters and all of them have to be arranged. So we don't have an R here. All of them have to be arranged. So how do we write this? 7p7, n is also 7 and r is also 7. This is the r. So I can write this as 7 factorial by 7 minus 7 factorial, or in other words just 7 factorial. So the answer is 7 factorial. For information, 7 factorial is actually 5, 2, 2 and 0. Let's move on to the next question here. Find the number of 4-digit numbers that can be formed using the digits 3, 4, 5 and 6. So I have 3, 4, 5 and 6. I only have 4 digits here. Okay, and I have to find 4-digit numbers only. So obviously I have to use all these 4 digits. Now there are 2 cases here. Okay, we have 2 cases. Case 1 is no repetition is allowed. So this means that I will have to use each of the digits at least once. Okay, so I have 4 digits and I have to form a 4-digit number. How many different permutations are possible? 4p4, which is nothing but 4 factorial, so 24. Okay, case 2. Case 2 is that repetition is allowed. It means I can have a number like 3, 3, 3 and 3. I can use the 3 4 times. What is the answer in this case? I have 4 digits to be filled up. The first place can be filled up in 4 ways. I can choose any one of these 4 digits, 3, 4, 5 and 6. Similarly, the second can be filled up in 4 ways. The third can be filled up in 4 ways. And the fourth one also can be filled up in 4 ways. Since I have to choose all 4 digits, it's a 4-digit number. So it's a case of and. I have to choose the first digit and the second digit and the third digit and the fourth digit. So the answer is 4 into 4 into 4 into 4, which is nothing but 4 raised to power 4. So generally in the question it is mentioned that repetition is allowed or repetition is not allowed. Just take care of what is given in the question and then solve accordingly. Yeah. So let's try another question on permutations. Now this question is slightly different from the one we've discussed before. Here they've asked us to find the number of 4-digit numbers which are greater than 4000 and that can be formed using the digits 3, 4, 5 and 6, and we have two cases here. In the first case the repetition of digits is allowed and in the second case it is not allowed. So we'll solve the first case here. As before, I will draw 4 dashes here as it is a 4-digit number. So for this first place, how many ways can I fill this place? I have 4 digits, 3, 4, 5 and 6. Now I have to form a number greater than 4000. So 3 cannot figure here, because if 3 comes here, then I'll have a number like 3, 6, 5 and 4, which will not be greater than 4000, or a number like 3, 5, 4, 6 or any number starting with 3. So I cannot have 3 here. So this number can be filled up in 3 ways. I can have any of 4, 5 or 6 occurring here. Now for this second space, since the repetition of digits is allowed, I can have any of these 4 digits, 3, 4, 5 and 6. Even 3 can occur in the hundreds place. Why? Because if the number is starting with either 4 or 5 or 6, if 3 occurs at the hundreds place, it is definitely going to be bigger than 4000. So this can be filled up in 4 ways, this space. Similarly, this 10th place can also be filled up in 4 ways, and similarly the units place can also be filled up in 4 ways. So what is the total number of numbers that I can have? I can have 3 into 4 into 4 into 4. These many numbers. If you multiply, you will get this as 192, or we have 192 ways of forming a 4-digit number using these 3 digits which are greater than 4000. Okay, so let's move on to this second case in wherein the number cannot be repeated. So I can use one of these digits only once. Just let me change the ink color for the second case. So we do the second case where the number of digits is, where we have to find the number of digits but repetition is not allowed. So again I have 4 spaces here. Again here I can fill this space in 3 ways, as I've already explained in this case. Why do we have 3 ways? For the same reason, I can fill this in 3 ways. Now the hundreds place can also be filled in 3 ways here. Why? Because one of the numbers out of 4, 5 and 6, one out of these has already occurred here in this thousands place. So here I will have 3 and any 2 from these. I have any 2 from these 3 digits. So this can be filled in three ways. Like I can have 3, 4 and 6 if 5 occurred here. If 5 occurred here, then I can have just 3, 4, 6. So 3 ways. Similarly, for this hundreds place, I will have only 2 ways because I've already utilized 2 numbers here in this thousands place and in the hundreds place. And for this units place, I have just 1 way because there is just 1 digit which is yet to be used. So how many numbers will I have? 3 into 3 into 2 into 1, which gives me 18 numbers, which can be formed if repetition of digits is not allowed. Now this same question can be solved in another way. I'll tell you that other way by changing the ink color. Now, as we've discussed before, the total number of 4-digit numbers that can be formed using the digits 3, 4, 5 and 6 is 4 factorial. This we've already discussed. But this 4 factorial also includes numbers which begin from 3. For example, 3654, 3654 or 3456. But these are the numbers which I do not require here because I want a number greater than 4000. So from these 4 factorial numbers, I need to deduct these numbers which start from 3. So how will I do this? I'll fix the first place. I'll fix the thousands place by 3. Okay. So now I have 3 spaces to be filled here. These 3 spaces have to be filled by 3 numbers 4, 5 and 6. In how many ways this can be done? 3 factorial. So now my answer is 4 factorial minus 3 factorial because this 3 factorial gives me the numbers which are starting from 3. So I have 24 minus 6, which is nothing but 18. The same answer I got here. So anyways, you can solve this. Okay. So let's move on to the next practice question here. There is a lock which has 5 rings. On each ring there are 4 letters. Okay, so I have drawn a lock here. So this has, for example, this has 4 rings, just 1, 2, 3 and 4. But in the question we have 5 rings and 4 letters. 4 letters as in here, see, we have 8, 9, 0 and 1. So these 4 letters. If only one of the combination opens the lock, then how many maximum unsuccessful attempts can be made? So I have here 5 rings. I draw here 5 dashes for these 5 rings. Now all these 5 rings have 4 ways. Like I can, if I go by this lock here, I can have 8, 9, 0 or 1 here. Similarly, this also has 4 ways. Here also I can have 8, 9, 0 and 1. Similarly, this also has 4 ways. This also has 4 ways. And this also has 4 ways. Now, we all know that in a lock, there is only one correct combination which will actually open the lock. So, how many maximum unsuccessful attempts can be made? I will assume that for maximum that I try all the combinations that are possible, and at the last combination I open the lock. Means at the last attempt I am actually successful. So how many total combinations are possible here? 4 into 4 into 4 into 4 into 4, which is nothing but 4 raised to power 5. Okay, and how many of them are unsuccessful? 4 raised to power 5 minus 1, because there is only one combination which will actually open the lock. So what is the maximum number of unsuccessful combinations that can be formed? 4 raised to power 5 minus 1. I hope this is clear. Let's have another question here. Arrange the letters of the word garden in such a way such that case 1, A part, there is no restriction. If there is no restriction, I just need to count the number of letters in the word garden, and that many factorial is the answer. So I have garden, this has 6 letters So the number of words that can be formed if there is no restriction is 6 factorial. Okay, which is nothing but 720. How many words start with n? So whenever you have this kind of a question that the word starts with n, what I'll do here is I will assume that the first word has already been chosen, the first letter has already been chosen, and that is n. So now I have 5 more spaces to fill here. Okay, because we had 6 words for garden, this n I already put here, so I have n. So I have to arrange the remaining 5 letters, these A, R, D, E, G, in this 5 places. In how many ways this can be done? In 5 factorial ways, which is 120. So the answer to the second question is 120. Let's move on to the next case. Now here we are given that all vowels are together. Okay, now listen very carefully to this option because this is very frequently asked in all competitive examinations. Now I have these letters G, A, R, D, E and N. I need the vowels to be together. So what I'll do is I'll take this A here and this E here and I'll stick them together. I'll consider it as one letter AE. Let's assume this is a one letter AE. So now if I take 2 letters and combine them into one, I have how many letters left? I have just 5 letters left. I have AE as a 1. I consider them as 1. AE is 1 letter now. So AE, G, R, D and N. So I have these 5 letters which have to be arranged. So these can be arranged in how many ways? 5 factorial ways. But all vowels have to be together. If AE is a letter, I can also have EA as a letter. Both are true. So for EA, I'll have another 5 factorial set of words. So 5 factorial plus 5 factorial or 5 factorial into 2 is the answer, which gives me 240 words. Okay, which has all the vowels together. So whenever you are given that some people are together, or let's say Ben and Alan are sitting together in any combination, just consider them as one entity, form a factorial considering as one entity and taking the rest of the people there or the rest of the letters as in this case, and then you can also rearrange them, like AE could also be arranged as EA. Consider for that and then just find the answer. Don't forget that AE is possible, so EA is also possible. Most of the people mark the wrong answer because they fail to recognize that we can also reverse the letters. Let's take the last option here. We'll solve it here. Vowels at the first and the last position. So if I want a vowel at the first and the last position, what I'll do is I'll draw 6 dashes here. I'll write a vowel here. Let's say I write E here and I'll write A here. The first and the last position, I fix them. Now the rest of the words can be arranged in, the rest of the letters can be arranged in how many ways? 4 factorial ways. So I'll have 24 words which have E at the beginning and A at the last. But I have another case where A can occur in the beginning and E will occur in the end. This will also give me 4 factorial words. So my answer is 24, which is 4 factorial plus 24, or in other words 48 words. Okay, so keep in mind here that you can always interchange. E and A are interchangeable.